Okay, so I have a very interesting talk called "You Could Have Invented Azure Synapse," and thanks to Microsoft, I've had to amend that to for Microsoft Fabric because a lot of stuff has changed, and so there's old Synapse and new Synapse and all this kind of stuff. And so what I'm focused on is what I kind of see as the path forward with Microsoft. And my goal is to help you, if you've never really done anything with Synapse, never done anything with Data Lake, start to get your arms around it. Um, Now, I work as a business intelligence consultant. So I work with Power BI and Microsoft reporting. I have courses on Pluralsight. I'm a Microsoft MVP, which means I do things like this and present. And importantly, I am not a Synapse expert. I would say I'm not a Fabric expert, but I don't think those exist yet since it's only been out for a month and it's still in private preview. And in fact, when I decided to start learning about Azure Synapse, I really started to struggle. Now, a lot of the things that were a frustration for me have been resolved with Fabric because it's a much more cohesive product. But I'm still trying to learn this kind of stuff. And so, what I wanted to do was make the kind of presentation that I wish existed and was out on YouTube to help me start to get my arms around all of this. So, what we're going to talk about first thing is like, what is going on? Why are we suddenly all using data lakes? What is happening? And we'll go through a kind of realistic but contrived scenario of how you could have invented Azure Synapse, or at the very least, how you could have gotten to somewhere similar. And so we'll start with how does it start? And then suddenly, oh, we accidentally have a data lake. And kind of end with, okay, here's some of the value that I see with Synapse and Fabric and all these sorts of things. So the first thing, what is going on? That was kind of what went through my mind when I decided that I wanted to branch out of Power BI and start to learn a little bit about Synapse. And one of the first questions is like, why is everything in a data lake now? How did we get here? And more importantly, why should I use Azure Synapse? Why should I use Fabric or Fabric in this case on the slide? I'll have to fix that. Um, why is this going on? Because I remember these presentations from a decade ago about big data, and somehow we've ended up here. And part of the challenge for me is I used to be a database administrator, and now I do work with Power BI. And so when I hear flat files, I hear data lake, I hear a lack of structure. It just doesn't quite make sense to me. And I have a very strong preference for databases. There are a lot of things that I like about databases that when I first start looking at this stuff, I don't see. And so a big one is SQL support. SQL is by far the data manipulation language that maybe short of Excel formulas, everyone knows. This is what I was taught in college. Technically, it was for MySQL, but I've run into a lot of users who are not super technical, but they know SQL, or at least they know enough to be dangerous. And so you can't run SQL queries on CSV files, at least not normally. We could talk about SQL serverless or that sort of thing, but by default, if I download some Excel files, if I download some CSV files on my machine, I can't query them. They're not a database. Another thing that I like about databases is coherent data types, right? Again, if I have just a text file, if I just have a CSV file, I don't get any data types with that. And that's fine at first until you start to deal with issues like, oh, well, us Americans do the whole date system backwards. We're never going to accept metric. And so if I have a text file or a CSV file and the date is 02/01 2023, what date is that? Well, you don't know. You don't know if that's February 1st or not April, or January 2nd, right? When you have data types and you have an existing structure, you avoid a lot of those issues. And so these are issues I run into all the time as a Power BI consultant, Power BI developer, because oftentimes we're pulling data from places where we don't have those data types or we don't have that structure or it hasn't been cleaned. Another thing that I really like about databases is databases have these secondary and primary structures to support performance. So when you make a database in SQL Server, as long as it's not a heap, as long as you have some kind of primary key, then you have a clustered index in 99% of the cases, which means the data is sorted in a particular order. And in addition to that, there's a structure called a B tree that makes it so it's very easy to jump to exactly the data you need. And in addition to that, you can add non-clustered indexes. You can add indexes that allow you to grab a subset of the data that you need. In addition to that, you have statistics. And so SQL Server, if you have a bunch of information, let's say sales or census or something with addresses, well, SQL Server understands that there's, say, 55 million people or however many million people in California and 500,000 in Wyoming. And so it's able to give you better query plans because it has that information available. And again, CSV files, flat files, you don't get any of that. Another thing is ACID compliance. I like to know that my data is accurate. I like to know if I make changes, that it's going to be written in a way that's complete and consistent and gets saved. And then finally, point in time recovery. I, as a former DBA, have dropped a table or two before, and being able to restore that is a big deal. Or you have a situation where someone edits a row, deletes a row, and you want to be able to go back to that. You can't do that with just a text file. And so my natural tendency is to say, well, why don't we use a database? It has all these benefits. And another thing with trying to, when I hear people talk about data lakes or all this kind of stuff, is they talk about a terabyte of data, terabytes, petabytes, whatever. And with the customers that I work with, our data is not that big. We're measuring in gigabytes. And so what is big data? Well, I think a lot of us have attended these presentations from a decade ago when Hadoop was the big thing with the 5Vs, volume, velocity, veracity, all this kind of stuff. And it never quite clicked because the thing that would frustrate me about those presentations is it would be an hour of like fluff. There wouldn't be particular examples. There wouldn't be anything to kind of ground it in so that I could understand, okay, where is that line? And there's a joke that big data is basically anything that's too big for your machine or too big for your laptop or whatever. And over time, that threshold has changed a lot, right? When Hadoop first came out, it was necessary because consumer laptops were running 4 GB of RAM and we needed a way to take advantage of commodity hardware. Now, on this desktop, it came with 32 GB of RAM from Walmart, and I've upgraded to 64 GB of RAM, right? A decade ago, this would have been a big data cluster. And so let's start kind of where Power BI users are starting, where my customers are starting. Let's start small. So we have a database. We have a transactional database, and often with the customers that I work with, we have a Microsoft SQL Server database on a virtual machine somewhere, right? It may be Azure SQL, but a lot of times we're still dealing with infrastructure as a service or VM somewhere. And the reason that having a transactional database is so important is because that runs the software that runs the business. So if you're running accounting software, if you're running an ERP, so an enterprise resource planning software, there is a very, very good chance that it's running on a transactional database. Now, there are things like Microsoft Dynamics Online and all these sorts of things, but generally, again, 90% of the time when I'm working with a customer, that's where we're pulling data from. Now, there was one customer that I had, it was one guy, and he was reading gigabytes of CSV files from telecom data, but most of the time we're dealing with the database. And then in order to make reporting easier, we feed that into a data warehouse. No, 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 no. I'm just kidding. It's actually just Power BI. Again, with these small customers, they don't even have a data warehouse. The data warehousing happens in Power BI. And so when I'm helping them get started with this all works pretty well. And there's a spot where it starts to break down and where the idea of doing a data lake or something starts to make more sense, or at least makes more sense to me. And it's when they say, oh, we just need a simple integration, right? If the data lives in the transactional database already, if it's part of an application, then generally it's easy to work with. But a lot of times there's other systems that we may not have complete access to, that we may not have complete control over. So a common example is if we're importing data from some sort of online system. So that might be customer relationship software, that might be sales software. So for example, Salesforce is a very popular piece of sales management software. And so you can imagine a situation where you're pulling data from APIs. And so you're getting these exports as CSV files or Excel or some other kind of file format. And so this customer might say, well, why don't we just put it in Power BI? And that works really, really well up to a certain point. Power BI is very good at this. It was designed for this because it started out as a set of Excel add-ins and was designed for the users that were living in a file share somewhere, either on the local network or in OneDrive or whatever, and they didn't always have good access to the SQL database. And so they often had exports from those ERP systems, from those accounting systems. And so this works for a while. And again, where this starts to break down is whenever you have all of these different files that you're pulling in, it has all of these different steps that you're applying. And so if you've got a lot of files, performance with Power BI for reading those files gets really, really bad, right? So if you're reading like a dozen CSV files, Excel files, it's not too bad. But because CSV files are uncompressed, have no data types, and because Excel files they're basically a bunch of XML inside of a zip file, you end up with a lot of this repeated effort and a lot of CPU that gets spent. And so, like I said, I had one customer who all of their data was not in a database, it was in gigabytes and gigabytes of CSV and Excel. And it would just chug super, super slow. Um, Another area where it breaks down, like I said, is you have lots of cleanup steps. Again, Power BI is great whenever you have maybe a handful up to a dozen steps, but it started out as an Excel add-in, as this graphical user interface tool, and trying to manage all of those steps becomes a governance nightmare, right? Because okay, where do you go to find the data logic? Where is it being applied? Is it commented? Does it have descriptions? Does it make sense? And with Power BI, oftentimes it's a very linear thing with Power Query for applying those different steps. And so it works great for a few things, but if you have more complex logic, it's not. Another thing is if you want to reuse that logic. Now, you could pull that Power Query into a data flow and reuse it that way. But again, that can potentially have its own issues. And then finally, the moment you want to use any other tool, then this doesn't quite work as well. And again, Power BI has the old data mart thing, but overall there's some limitations. So at a certain point, as you start to deal with more of this kind of data that doesn't live as part of your accounting application, doesn't live as part of your ERP, but you want to integrate it, at a certain point you have to put it somewhere and that's going to be more accessible, more manageable, more centralized. And so again, my first thought is why not the database? Why not put it in the database? We've had these for longer than I've been alive and they work pretty well. And so the first issue is that storage is expensive because you think about it, databases, relational databases are optimized for minimizing how much storage is used, for reads, writes, and transactions, and for speed. And so what that means is that you want to use fast storage. And so oftentimes you're looking at things like SSDs. oftentimes you're looking at more expensive storage. Another issue, and this is less of an issue with the cloud, but definitely an issue with virtual machines and especially physical machines, is that compute is often tied to the storage in the sense that it's not super easy to take a SQL Server virtual machine and just scale it up and keep the same amount of storage, or vice versa. Especially because if you have a virtual machine, you're probably looking at paying by the core. And so licensing gets to be a giant mess with that. And speaking of, SQL Server is expensive. Um, it's been a while since I looked. I want to say it's like 17 grand for a 2-core pack for Enterprise Edition, something along those lines, but it's a significant expense. And so if for data that we're not sure what we need and what we want to do with it, putting the SQL is really expensive. And SQL doesn't scale cleanly and linearly. That's one of the things that's really important to understand is as you go from 10 gigabytes to 100 gigabytes to a terabyte to 10 terabytes, it doesn't get proportionally difficult. It gets much, much more difficult because once you start getting into the terabyte range or the multi-terabyte range for your database, you start to have to do very complicated things to maintain it for the care and feeding. And you need an expensive DBA to do that because you have to think about maintenance for those statistics and indexes that I mentioned that I like so much. Well, now you're having to find windows when you can, of time that you can do that. You're having to get more complicated with your backups because you can't just do a full backup every night for your terabyte database. So you're doing a full on the weekends and you're doing a differential at night and you're doing all these transactional backups and all this kind of stuff. Another thing is we have to predefine our schema, which is normally a good thing. But a lot of times when you're getting data like what we're talking about, it's a bunch of stuff. The value of that data is concentrated in just a tiny piece, but it's not always clear upfront what stuff you need because you've got columns that are unnecessary, or you may be forced to pick certain data types that aren't optimal. You may risk losing detail. Finally, the database is optimized, like I said, for transactions, for these very quick reads and writes and change. And the type of data that we're talking about, whether it's coming from logs or APIs or these sorts of things, very often tends to be append only, or at the very least, it's receive only, and you're not making changes, right? And so something that helped a lot of this click for me is a definition of big data from Jordan Tigani from a really, really great blog post called Big Data is Dead, where his definition of big data is when the cost of keeping the data around is less than the cost of figuring out what to throw away. And this is where, on the smaller end of things, data lake gets interesting to me. Is okay, we're not entirely sure what we need. Like you look at this and you say, what do we need? Do we need a row GUID? Well, we might find out later that we need that for some kind of join, but probably not. We probably don't need the comments, all these sorts of things. When I'm working with Power BI and I'm doing reports for people and helping them get started, I'm very commonly just chucking stuff out. And with Power BI, that's fine because I'm pulling data from a database and we can always add it back in later if we need to. So, okay, we've decided we don't want to put it in a database. We need to store it somewhere. What's the cheapest option? And so the cheapest option is probably some like spinning disk hard drives in your house, but the next cheapest option is Azure Blob Storage. Now, Azure Blob Storage has a lot of things going well for it. There's a lot of things that we really like about Azure Blob Storage. First, it has tiers. And so the cool tier, if you're just storing data and you're not sure if you're going to need it, is very, very cheap. It's a cent per month per gigabyte. And so $10, if I can do math right, a month for a terabyte. Whereas if we were paying for SSDs, it'd be something more like $150, $180 a month, right? Closer to the premium price here. Now, there's an issue though, is blob storage is considered an object store. And so this is something that threw me for a loop. It's not a real file system format. Folders aren't real. It uses something called a flat namespace. And so what that means is folders are just kind of part of the name. And part of that is that this type of storage is optimized for, say, individual web files and similar sorts of things. It is amazing if we want to just share files for our website, or if we just want to stream data, or we want to do something like that. But what you end up getting is, imagine that I gave you a USB disk, a thumb drive, and you were not allowed to create folders, but you had all this data that you wanted to store, right? Well, what would you do? What you could do is you could pretend to have folders by naming it that way, right? So here we have our raw, cleaned, and we've got our data lake, everyone. We've done the medallion architecture that we've talked about today by just naming stuff. And so this is what you get with blob storage. And so, okay, our little model's a little bit bigger now, but it doesn't quite work. Blob storage is not enough, and there's a couple reasons for that. So one is our data needs cleaned. Again, ideally, the data that's coming from a system that's already the way that we want it, but oftentimes there may be things. I was working with a customer today. They were pulling data from, they have a bunch of Excel files, and sometimes the company name for one of their customers would have a space in it somewhere that didn't belong, and so we had to trim the data. We had to, get rid of the white space. Or maybe we want to have a subset of all these columns for the stuff that we focus on. So we need a tool to do that ETL, to do that cleaning. And so in this case, it's Azure Data Factory. But we also need staging now, because we want to be able to have, at the very least, okay, here's the raw data that we put in cold storage and we're keeping for forever. But then we want data that, okay, we've gotten rid of the stuff we don't need, or we fixed some things up, or at least we've had some more consistency. And we want to do it somewhere where it's not just in Power BI. And so then we actually do need folders. And so the fancy name for these is hierarchical namespaces. And so what we would use is Azure Blob Storage, which is Azure Data Lake Storage, which is built on Azure Blob Storage. And so this gets us some benefits. So now we have an ETL process. We can put it under source control. Other people can see it, can view it. It's not just being hidden away in a compartment somewhere in Power BI. We have data lake storage, which is designed for interoperability. So tools like Hadoop and Spark and all these other things that aren't necessarily Microsoft technologies can easily read to it. And we're able to start thinking a bit more about security and how we want to manage the security of all these different pieces. And so, okay, it's getting a little bit more complicated, but this is still kind of manageable. But unfortunately, we still have a performance problem. So we've got some structure, we've got somewhere to put the files. It turns out CSV is a really bad file format. Now, it is great for humans because I can take Notepad, I can take Vim. If you're on Linux, you could run Nano. I can take any text editor and I can read a CSV file. But there's no data types. It's just text. And like I said, that makes the data more error prone, potentially, or at least requires more work to determine what types you have. But again, it can also be kind of hard on the CPU. You run the risk of errors. You run the risk of it's doing a lot of work it does not need to. Again, when Power BI is reading gigabytes of CSV files, it will just chug. Another issue is that you get no compression. You could have the same value repeated over and over and over again, and it'll take up all that space. So, we're trying to save money. We're trying to make things simple. No compression's unideal. The other issue is that we get no pruning or predicate pushdown. And so we're reading in potentially all of the data where maybe we only care about the last 2 years. Maybe we only care about a subset. Now we can cheat a little bit with folder partitioning now that we have folders. And so you can do things where you can say, okay, I'm going to partition by year and month and day. And so if I only care about the last 2 years, then I'll look at just the last 2 folders of years. But we can do better. We can do better than this. So let's steal the idea for Power BI. Power BI uses the DAX engine, which is a column store engine. It does in memory, and that's how it gets such amazing performance. Well, okay, why don't we do something like that? Because if we're putting data in data lake storage and we want to be able to read it into Power BI at some point, then we care about analytics. We don't care about transactions. And so the ideal format for analytics is columns. And so we have something called the Parquet file format. And so this is a column storage based format. And so this is perfect for analytics because if you've ever worked with Power BI, then you understand that a lot of this analytical reporting is you need like 5 columns, right? You need 1 or 2 to aggregate on, you need a couple to filter on, and that's it. But usually you need the whole column, you need all of it because you're looking at multiple years worth of data, or you're looking at multiple regions or whatever. You're looking at this big vertical cross section of the data as opposed to an individual transaction or two. Another benefit we get with Parquet is now we can do column pruning. So before with CSV, we had to read a whole file, all of the data, and then throw stuff out. Well, because of the way that Parquet is arranged, we can grab just the columns that we need. Next, we get data types. And so now our file format is saying, okay, this is a date, this is a number, this is whatever. And so there's no more of that ambiguity, right? If you've ever pulled in an American zip code and it's truncated the 0 at the front, you know what we're talking about. Or if you've dealt with dates in Excel and it's decided that, January 1st is the number 1 or vice versa, you know what I'm talking about. And then finally, Parquet is an open file format. It's an open file specification. And so, okay, now we're starting to get somewhere. This is starting to make some more sense, but we still have a performance problem. It could be better. And even though we decided we didn't want to use a database and we weren't concerned about all this kind of stuff, turns out transactions are still useful and still good. And so we want to look at expanding Parquet. And so something that you probably hear about a lot is Delta. So Delta is an enhancement of Parquet. And it is basically Parquet files with Delta logs. And so the idea is that instead of just having this one big file that has all of your data that's been compressed into this column format, you're able to do adds and deletes and checkpoints and basically start to get something that looks a lot like a database. Now, from my understanding, you still have to be careful about some of this stuff because you can get a lot of fragmentation with all these little files and sort of things. And so there's some cleanup work. But it gets to be kind of funny because at the very beginning of the talk, I was talking about how I like databases for all these different reasons. And it feels like we've started to go full circle to come back to these things, but with Delta Lake, with using the Delta format. So as far as I'm aware, we don't inherently natively get SQL support out of the box. But like before, we do get data types. We get useful data types that avoids a lot of the frustration that you have with text files and CSV, and to some degree Excel, depending on how it's configured. We finally get that back. In addition, we sort of get indexes and statistics for performance. So like I mentioned before, you can do a lot with folder partitioning and that sort of thing with how you lay out your data lake. In the previous presentation talked about some of that stuff. But Delta also gives you some basic indexing and statistics. It gives you the ability to Z order. So you can do some ordering so that similar data is closer together. And you can also do data skipping as a result, where with the files, it will store the minimum and maximum value. And so if you're filtering on something, it may say, okay, I don't need this file because it doesn't have any of the data that I care about. You also get transactions. So we're back to ACID compliance. And because we have these logs for everything, we also get point in time recovery. And so, okay, we're starting to get some of the things that might have been hesitant to look at a data lake because we value this in the database. But, oh, we actually do want SQL. At the very least, SQL, as I said before, is a very, very common uh, querying language. Everybody knows it to a very large degree. And so it's just like the joke with business intelligence, where the most important feature is export to Excel. My friend Kevin Fiesel has this maxim that every big data tool is eventually going to have a SQL querying language. And I think there's a lot of truth to that. When it comes to Fabric, we've got two options available to us for how we want to be able to use SQL. So the first is the whole data lakehouse kind of approach. And so if we go with the lakehouse approach, we get a read-only SQL endpoint. So it's not going to have full T-SQL support. From my understanding, it's the same engine as SQL serverless. And so as a result, you may have slower performance. But for something like Power BI, where oftentimes we're doing import mode, we don't necessarily care about that. That's fine, right? What we're trading off on is we get a lot of convenience by being able to just put these files somewhere and have a schema around that, or part of a schema around that, and then put this kind of layer of SQL on top and just make everything easy for the report developer and for the final consumer. With Fabric, you can also do a data warehouse, and this supports reads and writes. Now, again, my understanding is that it's backed by Delta, and so I'll be interested to see what the performance is on the write portion, right? Because again, it's not like regular SQL Server, which is more optimized for that kind of stuff. Oh, all right. Andy did clarify the Fabric SQL engine is a supercharged version of SQL Serverless, the Polaris engine. One of the things that's actually interesting, if you search for the Polaris engine, there is a very, very in-depth research paper on it. There's some pretty interesting stuff there. And one of the other benefits that we get when we start to take this approach that I mentioned before is the common refrain that you see when it comes to modern cloud data warehousing is, can we separate compute from storage? Because what happens is, and again, if you read that that blog post, why big data is dead, what happens is data keeps growing, but your compute needs generally don't. And oftentimes it's incremental compute is what you need. And oftentimes you're looking at mostly just the recent data. And so we have this situation where by taking this approach, we're able to decouple storage from compute, and we're able to get an offering that better suits our needs in the long term. Like I said, if you're thinking about traditional SQL Server, that does not scale linearly. It does not scale well, or at the very least, it's hard to keep making it grow and grow and grow. Whereas you can take more of a tiered approach here and focus on the performance for the more recent data and have more of this cool storage or archival kind of data as well. So some benefits of Fabric and this kind of recent announcement, all this sort of stuff. So one is the SQL Server Analysis Services model, or software as a service model. I think that's one of the biggest reasons why we've seen this blend happen is, I think before with Azure Synapse, there was both frustration about, okay, what is the offering? Because you have all these different pieces that some are competing, some are supposed to fit together. Now it's one big offering, and the pricing is more manageable because you're able to just pay for capacity and you can scale that up and down, but you know what you're going to get charged. I've oftentimes compared the Azure approach to not only are you going to Lowe's or Home Depot to buy some lumber to build something yourself, but if you buy the wrong lumber, you get charged $5,000 per month, right? Whereas the premium capacity model, okay, with Power BI Premium, you're still getting $5,000 a month, but you knew that up ahead of time and you can scale up and down. Especially with Fabric, they've added much more fine-grained levels compared to Power BI Premium. Additionally, you have this singular UI and you can add all of these different Fabric artifacts. So things we didn't even talk about much were, the data engineering and Spark support, notebooks and machine learning and data science and all this kind of stuff. But it's all in one place. So you have, like I said, data engineering, data science, Power BI. Another feature that didn't touch on, but I'm really excited about is Power BI Direct Lake. So the whole thing with that is Power BI, as we talked about, is built on a column store engine. Parquet is a column store engine. And so someone thought, well, wait a minute. Why can't we just use direct query to talk to the data lake? And because it's already in a column store and because we have control over the ordering of the data and how it's compressed, we can make it so you can run your queries directly against the data lake. I have yet to test this out, but to me, like light bulb moment, very, very exciting. So I think you start to get a lot of benefits when you look at Fabric and in a way that doesn't require you to have to basically, like I said, go to Lowe's or Home Depot, be overwhelmed by all the product offerings, all the different pieces, and try to figure out how to build your own shed or build your own house, whatever your scale is, and risk paying this huge amount because you picked the wrong lumber, or you picked the wrong brick. So, should you consider Fabric? Personally, I don't see this as being a replacement for your transactional database that's running your accounting system. But I really, really like seeing it as a complement and the fact that it seems like they're providing an easy on-ramp. You want to experiment with this stuff. If you want to just upload some files and create a lakehouse, you can do that in an hour, right? And so the first question becomes, do you have a lot of flat files, right? Do you have a bunch of CSV files? Do you have a bunch of Excel files? Are you doing work today to read them into Power BI or somewhere else? Another thing is, do you want to support open source technologies? One of the big selling points of all of this is that it's much more interoperable with technologies that are not Microsoft based. Like I love SQL Server. SQL Server paid the bills for a long time. Power BI pays the bills today. But that doesn't necessarily make it easy to read from SQL Server from Linux. I know they have ODBC connectors and stuff now, but with Data Lake, one of the big selling points is that you can have a team with varied skills who are used to working in AWS, who are used to working with Kafka or Hadoop or Spark or whatever, with all these different open source technologies, and they can work with the data lake. You can have people who are data scientists or data engineers and are used to doing machine learning or notebooks, and they can work with the data lake. And so a related question is, do you see your data growing and growing to where, one, you have enough data to facilitate some of this machine learning stuff, but also you have enough data that it gets to be unmanageable to put that into a database, right? Do you think that you're going to risk ending up with more than a terabyte of SQL Server storage for a lot of stuff that's just probably junk, but there's some value there, right? And I think finally, is variable pricing a pain, right? Would you rather have a consistent, reliable, flat amount that you're getting charged every month with the ability to increase it or decrease it as necessary? All right. So that is me. In case anyone wants to contact me, here's my contact information. Otherwise, thank you everyone for your time.